Hello guys, so today I will explain you what is correlation plot and how you can find the patterns between the variables which are like you can say which are input variables or predictor variables, or you can say independent variables. So you should understand if there is any correlation between the independent variables or not. Say there are two variables which are highly correlated and they are correlated with 99.99% correlation, then that variable one of the if both the variables are used in the model, then uh, then it is not useful, because each of the variable is giving the uh, same information to the model. So we always try to see that if there are any variables which are very much highly correlated, and it depends on the situation. There is not a hard and fast rule that we should always remove the correlated variables. It depends, and there are techniques where you can, instead of just removing the correlated variables, what you can do is you can use the dimensionality reduction techniques to reduce the number of variables, correlated variables, into uncorrelated variables. So I'm not going into all those details, machine learning models details, but I am just going to tell you that how you are going to plot a correlation chart between the variables which are given in the data frame. So for that there is a library which is very useful and which is very cool technique, where you can see it very visually with colors and numbers, and there are many other methods where you can use and visualize the same chart with different kind of shapes and numbers. So I hope you know about what is this um, how to you must be using RStudio, I hope. And if not, then you should watch other videos, and if you are a very beginner, you can also, what you can do is you can follow my course on Udemy. This is the course which I'm talking about, and you can follow this course. I have given many lectures on this. Here you can see, and these are very in series, that these are in sequence that you can follow on, and you can practice to understand what are the things which are in machine learning. And so this is good for a very beginner who doesn't know anything about how to do machine learning in R and data science. So let's go back to this correlation plot, and let's say you must be having this. So all these colored bars, like this one, like this one, and this one, these are the functions which you need to write in R console, and then R. Then once you have got this core plot, so first you need the core plot. How you would do is that you install that packages core plot. Once this is installed, you can just import this library core plot. And also I forgot to tell, this is the website Analytics Data Exploration, where you can get this code for correlation plot once I am finished with this thing, so that you can also run the same codes and you can see that if this is working for you or not. So library core plot, and the data frame I'm using is empty cars, which is already built in the data set in the R. And so data frame, I have stored this data set empty cars. Now what you need to do is you need to convert this empty cars data frame into this correlation matrix. So what you would do is you just write core data frame. So in empty cars we have these columns. You can see what is in empty cars. You can just write head data frame. You will get all the variables and what are they. You will get the information of all those. This plot will tell about the correlation. Also, you must understand if there are some categorical variables you cannot do the direct correlation. Either you should convert that into some encodings, one hot encodings, and then do the correlation, but it doesn't make sense to do that correlation. But this is a correlation for numerical variables. So um, binary variables, then there is some Matthews correlation coefficient, and there are different kinds of correlation which you can use. But these are for numerical variables. When the variables are numerical, so what you do is, once you have written core data frame, you get the correlation matrix, and this is the correlation between the feature variables. So dark red means correlation is -1, and dark blue means correlation is 1, and white means 0 correlation. So you can see this bar. So dark blue is 1, that is the correlation, high correlation. So MPG is highly correlated with itself. That is, of course, that is correlation is 1. Each of the variable is correlated with itself with a value of 1. But there are some high correlations. But see, MPG and cylinder, number of cylinders, is negatively correlated. So if miles per gallon is very high, then the number of cylinders is very less. It is showing in this data. I'm not why is it so, but it is like that. If the miles per gallon is very high, and weight is also going to be very low. So -1 correlation. These are inversely proportional, you can say, in other words, but in very roughly speaking, you can say they are. But some are blue, like this one, HP, horsepower, and this, I don't know what is this one, carb, and this displacement, or what is it, and WT, this is another variable, so they are also positively correlated. So this is diagonal, and this is upper half and lower half. The upper half and lower half have the same information. You just, what you need to read, how you need to read is, if you want to see that this variable is how correlated to other variables, what you will see is MPG cylinder, this one, this is the correlation value. This color is negative, because in this you can see there, this is negative correlation. MPG, this, that is again negative correlated. MPG HP, it is again negative. MPG DRAT, this is positively correlated. MPG weight, then again negative correlated. MPG QSEC, positive correlated, or you can say not too much positive, but it is around 0. So you can say very less correlation between these two values. Now if you see DRAT and you see the correlation with QSEC, there is almost 0 correlation. Weight and QSEC, 0 correlation. So this is, now once you write the once you get the core matrix, correlation matrix from the data frame, what you need to write is core plot, and write this core matrix which you got from this, and then write method is equal to circle. So you will get this visualization. Another visualization is this, where you write method is equal to number. So you will get the numbers, what is the correlation value. So MPG with cylinder has negative correlation of value -0.85, which was shown here by the dark red color. Then again MPG with QSEC has some value which is positive 0.42. DRAT, it is 0.68. These are positive correlated values, and the variables are correlated with itself with value of 1. So cylinder with cylinder, this is 1. HP with HP is 1 correlated. So these are like correlation values. So you can just read the upper half or the lower half, because they both have the same information. There are other ways also to see, but what you can do is you can change the method, and you can get the different kind of visualization. So here you are getting the information that how the variables are correlated. You can choose in the linear models like linear regression, the variables should not be highly correlated, because they create problems in calculating the coefficients um, and they don't give the good estimate of the coefficients because of the interference of the variables which are very highly correlated. So we need to remove that. Either we can use the dimensionality reduction techniques to remove the highly correlated variables, or if they are very much highly correlated, you can choose to remove either of them. So that is different context we are talking, but in linear models we do not like linear regression I'm talking about, we should not have the highly correlated variables. In trees it doesn't affect too much, but still the correlation variables should be avoided. So thanks for watching this video. You can have a look on this code from here on this website, Analytics Data Exploration. I will be uploading more videos, and for beginners I would suggest to follow this course on data science and machine learning bootcamp with R. So this is on Udemy. You can follow this course, and thanks for watching. Bye bye.